Another technique we're going to look at to analyze roots and zeros and to help us with rational, is our upper and lower bounds theorem. And what this theorem allows us to do is, let's say we've guessed a number and we've now done the synthetic division. Wouldn't it be nice if the synthetic division told us whether we were guessing too high or too low? So if we didn't get it right, at least we would have an indicator of which direction we should perhaps check. So with that said, the conditions for the upper and lower bound. So the upper part is if I have a b that's positive. So let me kind of make note of this. So a positive number, positive b, that we're going to use synthetic division on, and the row that and I've done synthetic, and I end up with a non-negative entry, then b is an upper bound for the function. But again, and I'm assuming I start out with a positive number that, in other words, I can only test this for things bigger than 0. If the second condition for the lower bound, so if I have a negative number that I want to test for a lower bound, then using synthetic division, I would get alternately non-positive and non-negative numbers. Then I can say that that particular number is a lower bound for it. Okay, so there's sort of two conditions that we have to check. One, I have to check that when I've got a number that's either positive or negative. If it's positive, then I can check for an upper bound. If it's negative, I can check for a lower bound. And then I have to do the synthetic division and check and see what I get. Okay, so let's look at this particular example. So x to the fourth minus 3x squared plus 2x minus 5 lie between negative 3 and 2. Okay, so what I want to show is I want to show that 2 is an upper bound. So let me set up my synthetic division here. Alright, so 1, 0, negative 3, 2, and negative 5. Okay, and all I can do with 2 is I can only check that it's an upper bound because it has to be a positive number to check for upper. Okay, so drop the 1 and multiply, get the 4, multiply, get another 4, multiply, and we get 3. Okay, well, what do you notice about that list of numbers? See how they're all positive? Okay, so what that tells me then is that 2 is an upper bound. Okay, let's check the other one. So let's check the 3. So let me bring my list of coefficients over. So 1, 0, negative 3, 2, and negative 5. And I want to check that negative 3 is in fact a lower bound. Again, I have to have a negative number to check for lower. So I drop the 1, multiply, I get 9, that gives me a 6, multiply, negative 16, multiply gives me, 30 plus 16, so 48, I get a 43. Okay, so again, look at that pattern of numbers, and what that tells me is that negative 3 is a lower bound. Okay, so how does that play with the idea of rational roots theorems? How does that work with all those other skills that we've been looking at? It sort of helps narrow down when synthetic division doesn't give us the right number. Not meaning we made a mistake, but when we don't find a root, we can read more into what the synthetic division is telling us. So if I was to list out the possible rational roots for that function, so x to the fourth minus 3x squared plus 2x minus 5, right? Our constant term is the 5. Our leading coefficient is 1. So the factors of 5 are 1 and 5. So my possible roots would be plus or minus 1 and plus or minus 5. Okay. Now, what this whole upper-lower bound thing says, if I look on a number line, You know, here's 1 and -1. All the way out here is 5 and -5. I've already established that -3 is a lower bound and that +2 is an upper bound. So I know there's no reason to look outside of that interval for a possible root. So if I was working this one out, I would skip even checking 5 or -5 because I know those wouldn't pan out for us and give us a good solution. All right, so here we've got a nice lovely cubic. Let's just figure out what our possibles are and see how bad of a scenario we could have here. So let's look at our constant at the end, which is 10, and let's look at our leading coefficient, which is 1. And so what are the factors of 10? We got 1 and 10 and 2 and 5, and the factors of 1 are just 1. Okay, so the possible roots are plus or minus, and I could have 1 over 1, 10 over 1, 2 over 1, or 5 over 1. Okay, so how many total possibilities do I have here? So I got 4 positive and 4 negative, so I got 8 possibilities. And before I start plugging in numbers and guessing, let's see if we can narrow this down a little bit. Notice, just looking at f of x, do we see any sign changes? So notice it starts off at a positive, right? So I have 0 sign changes. And what does that mean for us? That means that I have 0 positive real roots. Okay, so let's just think for a second. What on earth did we just find? Initially, I had 8 guesses. And now, just by looking at the plus, I've narrowed it down that no, I have 4 guesses. I don't have 8 anymore. There's no sense in plugging in a positive number at all. Now we could go in and plug in the negative, but now that I know that they are all negative roots, there's no sense in doing that. I know I'm just going to guess negative numbers. So let me set up our synthetic division. So x cubed, x squared, x, and a constant. And we'll collect those up. 12, 21, and 10. All right, and since I know I'm hanging out in the negatives, I'm going to start with -1. And let's see what we get. Let's see, so drop the 1, multiply, combine like terms, multiply, combine like terms, multiply, and we get a 0. Yay! That wasn't that hard at all. All right, so our function so far looks like, let's see, a -1 means it's going to have a factored form of x plus 1. And that 1, 11, and 10 means x squared plus 11x plus 10. Okay, now that looks like something that we can factor. Let's see, 10, yeah, 10 and 1. So x plus 1 and x plus 10. Okay, notice we have a multiplicity. We have a repeated factor of x plus 1 squared times x plus 10. But our task was to find zeros. So where would this cross the x-axis? It would cross it at -1 and at -10. Okay, so going back to Descartes' rule of sign, that's sort of sped it up. It was really nice that we found the solution just after one try. All right, got a little nice, lovely 4th degree polynomial. It's a quartic. It's a technical term for that. All right, so let's start with rational roots theorem. Look at our possibilities. So we'll go for the constant as 8. Now I know it's negative, but remember we got plus or minus we got to look at. And then the leading coefficient is 1. So what are the factors of 8? We got 1 and 8, 2 and 4, and that's it. So our possible roots would be plus or minus 1 over 1, 8 over 1, 2 over 1, and 4 over 1. Okay, so we got 8 possibilities. Before we start guessing and checking, let's see if a rational roots theorem if Descartes' rule of signs sort of saves anything for us. Let's see, gotta scroll down here. We got positive to negative, negative to positive, positive to negative, and then it stays negative. So we have 3 sign changes, which indicates that we have 3 or 1 positive roots. Okay, so I know that there's at least 1 positive root, and I could have all the way up to 3 positive roots. Okay, so that said, let's see. Let's try the negative one. Let's do just negative real quick. And the nice thing about the negative is we understand what taking something to an even power versus odd power does. So if I take a negative to the 4th, I still get a positive number. If I take a negative to the 3rd, the negative comes out. So a negative times a negative, I get plus x cubed. So this is squared one. So a negative squared is positive, so we still get plus 2x squared. A negative times the negative 4, so I get a positive 4x, and then minus 8. And then look at our sign changes. So I only have 1 sign change. So that tells me that I have 1 negative root. Okay, so helpful or not, at least we're aware. But again, either we have 3 positive roots and 1 negative root, or we do have imaginary roots that could show up in this. Okay, so let's make our list x cubed, x to the 4th, x cubed, x squared, x, and a constant, and our list of coefficients. So 1, negative 1, 2, negative 4, and negative 8. All right, now at this point we're back to guessing. There's really not any reason why I'd pick one of the positive or negative, since I got the possibility of at least one of each. So let's think the lazy man's route. Let's try positive 1 and just see what happens. So we'll drop the 1, multiply, combine like terms, I get 0. Getting me 0 there. So that's 2. Multiply. We get negative 2. Oh, not going to work for us, is it? We end up with negative 10. Okay, so I have tried 1, and it did not work. So let's try negative 1. Let's go with this counterpart. So I get rid of all of this. This is why we have erasers, right? All right, so drop the 1, multiply, combine like terms, and then multiply, and combine like terms, and then multiply. Let's see, so that would be negative 4. So I get a negative 8 when I combine like terms. Multiply, I get 8 and 0. Yay! All right, I got one. It was a negative 1. Okay, so our factored form so far, and I keep track of this, since negative 1 worked, the factored form would be x plus 1. And what does the 1, negative 2, 4, and negative 8 mean? Well, that's just a cubic now, so x cubed minus 2x squared plus 4x minus 8. Okay. Well, at this point we don't have any other techniques. Although that is looking pretty factor by grouping to me, but I'll let, if you want to be brave enough and try that, go ahead and knock yourself out. But at this point, let's kind of go back up here. Our Descartes rule of sign told us that we had one negative root. We found it already. So at this point, I don't have to guess any more negative numbers. I know I've got to have at least one positive root. So, and I know 1 did not work in the initial case, so it's not going to work now. So I'm just going to go to the next number. Let's try 2 and see if 2 works. All right, so drop that, multiply, we get 0, multiply, we get 4, multiply, we get, okay, look at that. We found another root. All right, so f of x equals x plus 1. All right, so the fact that 2 worked is, in factored form, it'd be x minus 2. And then that 104, that would now represent x squared plus 4. Okay. So if you look at what we got left, we got x squared plus 4 left. That's actually not factorable using real numbers, but we can solve using complex numbers. So as far as factored form goes, that piece is, that's our factored form. However, the question said find solve for x. So we're not done. I'm just emphasizing that's what the factored form is. And so I want to know that x squared plus 4, where does that equal 0? So that's x squared equals negative 4, which is, take the square root, so you get plus or minus. So I get plus or minus 2i. Okay, so we now have our 4 solutions. One solution was at negative 1, one was at a positive 2, and then we have plus or minus 2i. All right, so good luck on homework. Don't give up. Just keep trying. You'll get there. All right, so let's take a look at this last example, and let's start with our possible roots. So let's look at our constant at the end is 36, then our leading coefficient is 1. So what are the factors of 36? Well, I got 1 and 36 and 2 and 18 and 3 and 12 and 4 and 9 and 6. Oh my. And then obviously 1, we got 1. So our possible roots would be plus or minus, and I'm going to try to put these in some sort of order. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, so how many possibilities is that? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 18. Is that pluses and minus? So there's 18 possible numbers to guess and check from. So I would want to use our Descartes rule of sign trick and see if we can narrow that down, so maybe we're not having to check everything, right? So I'm going to go to the original function and just count my sign changes. So I go from positive to negative, negative to positive, positive to negative, and negative to positive. Okay, so I have 4 sign changes, which means I could have 4 or 2 positive roots. And I think it's worth it just to try the negative one. So let's try, see if we can figure out how many negative roots we might have. So if I take a negative x and I evaluate it into x to the 4th, a negative to the 4th power is still x to the 4th. If I do a negative cubed means the result would be negative. So a negative times the negative that's there already would give me a positive 6x cubed. Plus, well, let's see, square a negative, you get a positive, so plus 13x squared. Then we have that minus 24 times an x. So if x happens to be negative, then a negative times a negative is a positive, so plus 24x, and then plus 36. All right, well, take a look at what we got. I have no sign changes. They're all positive. Okay, but more specifically, what does that tell me about my possible solutions? It means I have 0 negative roots. Okay, so you know that scary amount of, we had 18 possibilities to check. We've now eliminated half of that list just by checking Descartes' rule of sign, and now we're down to positives. Unfortunately, all we have are 2 or 4, so that means we either have 4 good numbers or we have 2 good numbers and then 2 complex numbers. So we'll have to play that out and kind of see. So let's set up our synthetic. So we got 1, negative 6, 13, negative 24, and 36. Okay, so we got that. And all right, so let's kind of pick a number. Okay, so the only thing that upper bound and lower bound would tell us, upper bound would allow us to see if a number is in fact an upper bound. Lower bound would work if I had a negative number to try, but we've already eliminated all of our negative possibilities with the f of negative x. So unfortunately we can't figure out if something's a lower bound, but we can see if something is an upper bound if it happens to come up. So I would say, looking at this list, we could start with 1 and just work our way up. That's probably about the best strategy, is just start at 1 and see what happens. So let me do that. We'll start with positive 1. So drop the 1, multiply, gives me negative 5. Multiply gives me an 8. Multiply, okay, I can already see this isn't going to work because I'm going to get something that's not going to cancel out the 36. So I know 1 is not a good number. How about, let's try 2. So let's see if we can get the root to show up with the 2. Alright, so drop the 1. So negative 4, so we get negative 8. That would be a 5. So that's 10. Which is then 14. And still not enough. Okay, so 2 didn't work. Kind of keeping track off to the side here of what numbers I've tried. Alright, so 2 did not pan out for us. Alright, so the next number up would be 3. So drop the 1, multiply gives me negative 3, multiply gives me a 4, multiply, ooh, this is looking a little bit better. Negative 12, and that gives me negative 36. Alright, so yay, we got one. We got a root, yay. Alright, yeah, let's take a second, let me write this out so we can see what we've got so far. So we have x minus 3 in factored form, and we now have x cubed minus 3x squared plus 4x minus 12. Okay, ooh, you know what? That looks like a good candidate for completing the square. Let's try that real quick. Let's see, so I can take out an x squared, x minus 3, and then I can take out a 4 and get x minus 3. Okay, great, those two match. So we have x minus 3 squared, And then we have x squared plus 4 for that one. Alright, so that's our factored form for our polynomial. And our task was to find the zeros. So if I do x squared plus 4 equals 0, I get x squared equals negative 4. Take the square root of that, so it gives me plus or minus. So I get plus or minus 2i. Okay, so what are our zeros? We have 3 that has a multiplicity of 3, and I have plus or minus 2i as far as all of my nice fancy solutions go. Okay, and just kind of confirm what we already know. Since it was a fourth degree, that means there had to be 4 zeros. And yes, it just turned out 2 of them were imaginary, and according to our Descartes, we had 4 or 2 positive. We did have 2 positive, just happened to be multiplicity of, multiplicity of 2. Don't want to wrote a 3 there. So all is good. We got it.